Each day, thousands of feet of sanitary sewer, storm drain, and culvert pipe are installed throughout North America. Certainly not all pipe materials are installed the same way. Precast concrete pipe, corrugated metal pipe, corrugated high-density polyethylene pipe, and others. All of them have different characteristics. A properly installed pipe system begins with understanding these distinctions and then using this knowledge to design a pipe system that accomplishes the desired results. Today we're going to focus on differences in the installation process. We're designing a prototypical drainage system that's 1,000 feet long, using 3 types of pipe in the same location: rigid precast concrete, profile wall high-density polyethylene pipe, and corrugated metal pipe. Of course, designs and specs will vary depending on the pipe material, soil conditions, load, location, installation depth, and so forth. The project details include information on the pipe size, depth, soil conditions, backfill requirements, hydraulics, and load. Understanding these variables will lead to a successful design with efficient flow characteristics, durability, reliability, a long service life, and ease of maintenance. With me is Bill Nesbitt. Bill has extensive experience in the specification, design, installation, and rehabilitation of drainage systems. Bill's also conducted many seminars around the world with emphasis on proper pipe installation. Bill, why don't you start by explaining the key differences when installing different types of pipe?
Thanks, Bob. Regardless of the type of material, all buried pipe must accomplish the same important functions. Each type of pipe system must serve both as a conduit and as a structure, according to the designer's specifications. The conduit transports the liquid, usually stormwater or sanitary wastewater, in the required volume at the proper flow velocity from the point of inflow to the point of discharge. While transporting the liquid, the conduit must also limit infiltration and exfiltration to the designer's specified limits. The pipe system structure, which is provided by a combination of the pipe and the supporting soils around the pipe, must maintain sufficient long-term strength to protect the viability and dependability of the conduit. Rigid pipe, like concrete pipe, is designed and manufactured so that the pipe will provide most of the required structural strength in the pipe soil system. Frequently, RCP will provide 85 to 95% of the required structural strength in that pipe soil system.
Bill, what about flexible pipe systems?
Flexible pipes like corrugated HDPE and corrugated metal pipes don't offer a significant amount of the required structural strength in a pipe soil system. Structural strength provided by corrugated metal pipe, for example, rarely exceeds 15% of the required combined strength in that pipe soil system structure. Structural strength for most plastic pipe is even less. Let's keep it simple. When a rigid pipe, such as concrete pipe, is delivered on the truck at the job site, all of the conduit and most of the structure has arrived. When a flexible pipe, such as corrugated high-density polyethylene, arrives on the truck, the contractor has received the conduit, but very little of the structure.
So to install flexible pipe properly, the contractor needs to construct a soil pipe system to provide structural support. Well, won't he also need to provide additional fill or bedding material and labor to meet the engineering specifications for this support?
In most cases, that's right. For all pipe materials, he pays for the conduit delivered to the job site. With concrete pipe, the manufacturer provides the required structure in the delivered pipe. With flexible pipe, the contractor or owner must rely upon the installation crew to build the required structure in the trench with the proper embedment materials, proper placement of those materials, and careful compaction.
Bill, this might be a good time to explain the differences in embedment materials, placement, and compaction.
When the contractor installs flexible pipe, the structure must be built in the trench. This often means replacing the excavated soils with higher strength select granular materials such as crushed rock. In addition, the backfill material must be placed with greater precision and compaction. For example, at least 85 to 95% of standard Proctor density is generally required under the haunches of the flexible pipe as well as over the pipe to provide the required structure protecting the conduit. On the other hand, reinforced concrete pipe is manufactured to a standard class or a specified design strength using either the indirect design or the direct design method. This allows the design engineer to determine the amount of structural strength to be provided by the pipe versus the strength provided by the embedment soils. This often means that the contractor can use the existing in situ soils for embedment, even when the soils may not be considered to be higher strength. Corrugated HDPE pipe, as well as various other flexible pipe products, offer only one strength choice for a given diameter. Invariably, the primary structural strength must be provided by the embedment materials, which oftentimes must be imported to the job site. While the quality of the embedment materials selected for concrete pipe will impact the soil structure in the pipe soil system, the pipe will contribute up to 95% of the system's structural strength. So, haunching material is rarely critical for concrete pipe. Depending upon the indirect design pipe class or the standard installation direct design criteria, a stronger pipe may be used in weak soil, or a lower design strength pipe may be used in stronger soil. The designer may make the best economic and engineering choice. Another point to remember is that you can't just dump and slice in the placement of embedment materials when installing flexible pipe. More labor time is needed for installation of that product. To make sure the embedment material is placed and compacted properly, the contractor may be required to limit lift thicknesses to 6 to 8 inches to achieve the required density. He may also use more equipment, either the pogo stick type compactor for sands and fine gravels, or the vibratory plate compactor for coarse gravel or crushed rock. Another factor to consider is that flexible pipe, due to its relative light weight, can easily float off line and grade. This can happen during installation due to poor procedure, or after installation due to a high water table or a sudden downpour. This complication often necessitates special care, including meticulous placement and careful compaction of select embedment materials in shallow lifts to the proper depth of cover. It's common for a flexible pipe installation to require substantially more time than that required for the installation of rigid pipe. The relative weight of concrete pipe helps maintain its position without risk of flotation. The shorter lengths of pipe facilitate both grade alignment as well as simple and safe trench box techniques where required.
I understand that proper joints are also vital to the success of a pipe system.
Excellent point, Bob. Often we forget that the pipe joint is an important component of the conduit. It must not interrupt smooth flow of the liquids. Equally important, the joint must ensure that the engineer's infiltration, exfiltration specifications are satisfied. Also vital, leaking joints can promote migration of fine soil from the embedment materials, a critical problem if the migration destroys the structure so important for the flexible pipe the contractor works so hard to build in the trench soil. Once the flexible pipe deflects, joints become more difficult to assemble and are less efficient. Recognizing the importance of E', the modulus of soil reaction, for flexible pipe, the following critical requirements must be considered. 1. Selected embedment material must provide sufficient inherent structural strength. For example, crushed rock offers much more strength than sandy loam. 2. Embedment material must be placed carefully, protecting the pipe arch without moving the pipe off of required line and grade. 3. Embedment material must be placed particularly in the haunching zone without voids. 4. Embedment materials for most flexible pipe installations must be compacted to 85 to 95% of standard Proctor density. Obviously, corrugated HDPE as well as CMP is flexible on the top as well as the bottom. The contractor can't forget to protect the arch in the wall of a flexible pipe. If that arch is lost or compromised due to bad practice in installation or subsequent soil settlement, the structure in the flexible pipe is lost. The Romans learned long ago that a flat arch does not work. The structure fails, the conduit fails. The only happy folks are the lawyers.
Bill, what about when an installation isn't done properly? Won't the buried pipe have a shorter life as well as other problems?
The greatest folly suffered in the installation of buried pipes is the failure to ensure proper pipe soil structure. If the structure proves to be inadequate, the service life of a buried pipeline may fall far short of the minimum specified design life for the system. In such an event, replacement costs can be staggering. Lawyers will invariably place great emphasis on operational disruptions and on full system replacement cost as opposed to original installed cost. When the structure fails, everyone involved in design and installation becomes party to the inevitable lawsuit. Think of it as a time bomb waiting to explode.
No doubt you've heard the hype that flexible pipe is less expensive than rigid concrete pipe. Well, that's simply not true. When you total all the costs, material, labor, and other installation costs, in many cases, concrete pipe is no more expensive than flexible pipe. Just so we're comparing apples to apples, here are the relative costs for each of the 3 pipe systems we designed. Remember, pipe prices and backfill materials can vary from region to region, and these are examples only. As these figures show, on our prototypical drainage system with 1,000 feet of 24-inch pipe, by comparing all of the costs involved, concrete pipe is the hands-down winner. It takes more than proper specs and design to ensure a successful drainage system. As we learned today, it also takes a contractor with experience, knowledge, and the right tools to install the pipe as specified and designed. At the end of the day, you'll remember one key point. Your safe choice for any pipe system is precast concrete pipe. Long after the job's complete, you'll rest easier knowing it's a job that you can be proud of literally for the rest of your life.